So you're probably wondering, how are these digital train models built? Well, the first step involves the acquisition of data, processing of that raw data into useful information, and then representation. So acquisition of terrain data. This is where the surface information is collected. And there are a number of ways this information is collected, and each year that number grows as technology for gathering such data advances. And some of the kind of considerations or major factors involved in collecting this type of data often involves resolution and accuracy. So this has to do with the spacing of the points. If the spacing of the points are very, very small, it's going to be very high resolution and it's going to be more accurate. But of course, being able to collect that small resolution, it takes time and it costs a little bit more money, and sometimes the technology is not quite there yet. And like I said, it's constantly evolving, so it's something that is going to become more and more high resolution, and I can foresee in the future that this is going to be kind of the standard, that we're always going to get our data this way. So as I mentioned, it involves a series of points. So once it's collected, you have this huge point cloud. So now all of these points need to be processed. So the second step is the processing of the raw point data. So there are professionals who process the raw point data that was collected using laser ranging and scanning, for example, are familiar with the equipment used, look for certain horizontal and vertical errors in the points. Processing of these points can take time and it can be costly, but again, as technology continues to advance, the process takes less time. Then once the points are processed, we lead to the next step here, and this is representation or modeling. So this is where the landscape architect can now take the information that has been processed from the previous step and visually represent the output or model the terrain, basically. So how this is represented often depends on the target audience, what problem or design solution the landscape architect is trying to develop, and the applications available capable of handling the scale of the terrain data. So basically we're talking about here the quantity or the gigabytes of terrain data. So oftentimes you'll find that Civil 3D cannot process that large amount of terrain data, and that you find yourself in GIS. So it's one of the strengths of GIS is that it can handle vast amounts of data where other applications will usually choke on it. So the focus of this chapter will largely be on representation or modeling using the Autodesk Civil 3D software. We will use some other applications to kind of explore how do we take data from different places and get it into Civil 3D. So at the same time, we will not ignore how data was collected and processed. We will cover basic principles about data acquisition and processing such that the reader has a basic awareness of the journey and transformation the data took to arrive at the desktop of the landscape architect.